Why does time slow down? This may sound like science fiction, but it's actually a fundamental part of modern physics. Thanks to Albert Einstein's theory of relativity, we now understand that time doesn't flow at the same rate everywhere. It bends, stretches, and contracts, depending on speed and gravity. Is time constant everywhere? No. And that's the mind-bending part. According to Einstein's theory, time is relative. The faster you move, the slower time flows for you compared to someone standing still. This effect is known as time dilation. The faster you travel, especially as you approach the speed of light, the more time slows down for you relative to others. The twin paradox: who gets older? Let's visualize this with the classic thought experiment known as the twin paradox. Two identical twins begin on Earth. One stays on Earth, while the other travels through space at near light speed in a spacecraft. Years pass. When the space-traveling twin returns to Earth, they are younger than the twin who stayed. Why? Because during high-speed travel, their personal time passed more slowly. They experienced less aging. This isn't science fiction. It's measurable physics. Does time dilation affect real life? Absolutely. And we use it every day. GPS satellites, for example, must correct for time dilation. These satellites orbit the Earth at high speeds and at higher altitudes, where gravity is weaker. Both speed and gravity affect time. Without relativistic time corrections, GPS signals would become inaccurate by 10 kilometers per day, rendering your navigation app completely useless. How does this work physically? Einstein taught us that space and time are not separate things. They're part of a four-dimensional continuum called space-time. Massive objects, like planets or stars, curve space-time. The more mass, the more curvature. The stronger the curvature, the slower time flows nearby. This is also why time on the surface of Earth moves slightly slower than time on a mountaintop. Gravity affects time just like speed does. How much time are we talking about? In everyday life, time dilation effects are tiny. For example, astronauts aboard the ISS age a few milliseconds slower than we do on Earth. GPS satellites lose about 38 microseconds per day due to time dilation and gravitational differences. But at relativistic speeds, near light, time slows dramatically. And if we ever build light-speed spacecraft, it would mean astronauts could travel decades and return years younger than people on Earth. Can we use time dilation? Time dilation has potential uses in future space travel and theoretical physics. It also opens deep philosophical questions. What is time? Can we ever reverse it? Is time travel possible?